identifying key features of a function. So the first thing you want to do when you're identifying key features of a function is figure out where your maxes and mins lie, because that's going to help us, um, compile the rest of the information. So right down here, I see this is -10, but I'm going to go ahead and put a min here. And so let's figure out what this is. This is about -0.3. You can always just estimate if the value is not given. -0.3 and -10. Okay, so I got a minimum there. Then I look over here and I see a maximum right about here. And if I look at that one, that's going to be at about 1.8. And the y value is about 3. So we're going to say 1.8, comma 3 here. Next one is a little easier. It's actually an x-intercept as well, but it is also a minimum, and that's at 3, comma 0. Okay, so next, I need to write all of these. Well, I have an absolute min here. The reason I know it's an absolute min is because it never goes lower than that. The graph never goes lower than that point. Okay, so the absolute minimum here, you can just write the coordinate point, -0.3, -10. So now I have my absolute min. Now absolute max, there is no absolute max because notice these two arrows mean this graph would go up to infinity. So if there's no absolute max, you don't have to write anything. So let's move on to the local maxes and mins. Well, I got a local max right here, right, as it's increasing, and then it starts decreasing. So I have a local max at 1.8, oops, 1.8, 1.8, comma 3, and then I have a local min. I have a local min at 3, comma 0. Okay, so now I have all of those identified. X-intercepts, those are easy. We just look here and we find our x-intercepts. So those are going to be, and it's good to just write the coordinate points still. Those are going to be -1, comma 0, 1, comma 0, and 3, comma 0. So in this case, the x-intercept is also a local min. That doesn't always happen, but in this case it does. Now, final thing. We want our intervals of increasing and decreasing. Really important to remember that these intervals are written in terms of x. So it's increasing. We'll identify all those in a second here. So let's start with decreasing actually, because if you trace the graph, you can see that it's decreasing from positive infinity all the way to here. So what that means in terms of our interval is that it's decreasing from negative infinity, because really it would just go on forever, to -0.3. All right, next, it increases for a while. So we'll write down that interval in a second. So it's going to increase until it hits this max. Maxes and mins are always where it changes from increasing to decreasing, or the opposite way. So now it's decreasing for a little interval here, and then it's increasing until x goes to infinity, or as x goes to infinity is a better way to say it. Okay, let's finish up the interval of decreasing. So it's decreasing from negative infinity. Always be thinking of x like your number line here, negative infinity to -0.3. And then again at 1.8 to 3. So I'm going to record this, 1.8 to 3. And then the intervals of increasing are just the opposite of where it's decreasing. In this case, that's going to be -0.3 to 1.8. And again from 3 to infinity. And now we've identified everything, so we're done with this problem.